The first method for solving a quadratic or degree 2 equation is factoring. The factoring method is based on the zero product principle, which states that if A times B equals 0, then A equals 0 or B equals 0. That is, if I multiply two numbers together to get 0, it must be true that one of those numbers is equal to 0. Applying this principle to solving quadratic equations, do the following. Number 1, collect all terms on one side, leaving 0 on the other. Then factor completely. We have practiced this and you are ready for this moment. Then set each factor equal to 0, that's where our zero product principle comes into play, and solve for x. That should give us two solutions. Check both solutions by substitution. So let's give it a try on example 1. Solve the following quadratic equations by factoring. So the first thing I need to do is to get the equation equal to 0. So I'm going to move all of my terms to the left side of the equation. So I need to take this term and move it to the other side of the equation. And we can do that by adding it to both sides. Notice when I add that term to both sides, or I move it from one side of the equals to the other, it simply changes sign. So we end up with x squared plus 12x equals 0. Next, I want to factor that left side completely. So based on the pattern of the left side, we can see that there's a greatest common factor of x. So we're going to factor out the x, and that leaves behind x plus 12. Now we have the product of two numbers equal to 0. By the zero product principle, it must be true that one of those factors is 0. So we're going to set each factor equal to 0, including that little monomial factor there on the left, and then solve for x. So x equals 0 is one of my solutions, and subtracting 12 from both sides of the equation in my second, we end up with x equals negative 12. So look at the overall pattern of what we've done. We started out with a degree 2 equation, and we reduced it down into two degree 1 equations. So solving my quadratic equation is still dependent on our ability to solve a linear equation. Now, we're not quite done until we're sure that we have the right answer. So we need to check both solutions by substitution. So I'm going to take my first solution, 0, and plug it into the original equation and test to see if I have a balanced equation. On the left side we have 0, on the right side we have 0, so we know that x equals 0 is the correct solution. Let's check our other solution. So I'm going to take negative 12 and plug it in for x on the left side. Notice the parentheses there. I'm squaring the value of x, so I'm putting negative 12 in parentheses to square it. And on this side we have negative 12 times negative 12. So clearly we have a balanced equation here since both sides have the value of 144. So both of our solutions work. Now to be formal, remember when we see a set of curly braces, that indicates a set. So our two solutions, and I'm going to write them in numerical order, smallest to largest, would be negative 12 and 0. So I have both of my solutions included in the curly braces and separated by a comma. When you proceed to your My Math Lab homework, the curly braces will be set up ready for you to go. You're just going to type in your two solutions separated by a comma in the blank there. In My Math Lab, if you type x equals negative 12 or x equals 0, it will mark it wrong. It's going to interpret that as a vertical line, as we'll learn later on. So just remember, in My Math Lab, type in the numerical values for your solutions only. Okay, we factored that one by taking out the greatest common factor, but all of the factoring techniques that we've learned are going to be useful to us. Let's solve 2v squared plus 22v equals negative 56. We know this is quadratic because I can see the variable raised to the second power. So my goal is to get it equal to 0. So we need to move this negative 56 to the other side by adding it to both sides. This gives us 2v squared plus 22v plus 56 equals 0. Now clearly we have a greatest common factor of 2, so let's extract that. That's going to leave behind v squared plus 11v plus 28. And I want to pause right here for just a minute. It's really important when you're factoring not to lose your greatest common factor. However, in the context of solving an equation, because now I have two sides, I can clear that greatest common factor by dividing both sides by 2. Because on the right side, 0 divided by 2 is 0. So really, to solve this equation, I need to be able to factor this remaining trinomial. So that greatest common factor 2 really doesn't have bearing on the solutions to the equation. So this is a basic trinomial whose leading coefficient is 1. So we're going to break it down into two binomial factors. The first term of each binomial is v. Because of our signs, we can tell they're going to be the same sign. Both of them are going to be positive. So we need to find two factors of 28 with a sum of 11. And I think 7 and 4 will do the job. So now that we have two factors multiplied and equal to 0, we can set each factor equal to 0. So here's where we get two linear equations out of our original degree 2 quadratic equation. In the first equation, we can solve by subtracting 7 from both sides, and in the second, by subtracting 4 from both sides. So our solution set contains two values. Again, I'm going to write them in order from smallest to largest. -7 is one solution, and -4 is the other solution. To check our equation, we can plug both solutions into the original equation and check for balance. But I want to remind you, if your brain gets a little fatigued from the algebra, you can use your calculator to double check the arithmetic here. So I'm looking at the left side of the equation, 2v squared, and I'm going to replace the v with -7. Notice how that -7 is in parentheses. And I'm going to replace the other v with -7 as well. So that's the left side of my equation, and notice it has a value of -56. The right side of our equation also has the value -56, so we know we have a balanced equation. We can do the same thing with -4. And we have a balanced equation. So both of our solutions are correct, and we can be confident that we have both solutions. On example C, we're still solving the quadratic equation by factoring. And remember, in order for this process to work, all of the terms have to move to one side so that your equation's equal to 0. So we have 8t squared plus 29t minus 12 equals 0. Now, in this case, we don't have a greatest common factor. We do have a leading coefficient of 8, so we can factor this one by trial and error. We can break this down into two binomial factors. First of all, notice we're going to have two different signs in our factors, one positive and one negative. And the biggest product between our outside and inside terms will need to be positive. If you spend a little time playing with this, now remember these two have to multiply to give us 8t squared, and these two have to multiply to give us 12. Working with our possibilities and settling on the correct answer, you'd end up with 8t minus 3 times t plus 4 equals 0. Then we set each factor equal to 0. 8t minus 3 equals 0, t plus 4 equals 0, and we'll solve each equation for t. So adding 3 to both sides here, and then dividing both sides by 8. One of our solutions is 3/8. Subtracting 4 from both sides here, we'd end up with -4. So we came up with two distinct solutions. In order from smallest to largest, we have -4 and 3/8. But it's always a good idea to check our solutions. So I'm going to, again, use my calculator. Our problem was 8 times t squared plus 29t. So I'm going to replace t, first of all, with -4. And I'm looking for a value of 12. Remember, on the right side of the equation, we had a 12, so we can see we have a balanced equation. Let's also check our fraction solution. This time, I'm replacing t with 3/8. hoping for a 12, and we got it. So both of our solutions are correct. One more example, we have x squared minus 144 equals 0. We have the benefit of this equation already set up equal to 0, so all we have to do is factor it. Notice the left side is the difference of two squares. So we could factor this as x plus 12 times x minus 12 equals 0. Then we set each factor equal to 0. This creates two linear equations, and we can solve each of those linear equations by isolating x. In the first one, we subtract 12 from both sides, and the second one, we add 12 to both sides. So in our solution set, we've got two answers. In order from smallest to largest, we have negative 12 and positive 12. These you can kind of eyeball to check. If I plug in either positive or negative 12 here and square it, that's going to give me 144, and 144 minus 144 is equal to 0. So we can be confident that we have the correct solution. Your ability to solve a quadratic equation by factoring depends on your comfort level with factoring. So the good news is you're going to get some more practice with factoring, but it's essential that you can get it factored because that's where our solutions come from.